Okay. Number 9 has a little bit of a typo. That top line shouldn't be there. That top line should not be there. Okay, number 9, I'm needing help. Is this a function or not a function? I'm looking for help. Yes, table 6. It is a function. It passes that vertical line test, so yes, it is a function. And you can have a point.
Nope.
I'm looking for help with number 10.
Nope.
Yes, table 2.
It's not a function.
Not a function. I heard you, Seth, but okay. There's one point that's an issue. It fails that vertical line test here, but it also fails it here. In fact, I can draw lots of little spots where it fails it. Not a function. Yes, Seth, number 11.
No.
It is not a function either. It fails that vertical line test lots of places, but one specific place is here. We have an issue.
Like straight down the middle line.
Yes, you could. I mean, there are literally thousands of places I could choose, but just finding the one is enough. And then Kelsey, you've had your hand up for forever. Number 12. It is a function. Now, is it a pretty function? No. That sharp turn, does that make it a pretty one? No. But I can't find a spot where it fails that vertical line test. And then Paige, you've been trying to. You want to volunteer for that next one? Kelsey, you can have a point. It is a function. You table can have a point. For an extra point, can someone who's had math class before tell me what number 12 is? What kind of function it is?
Linear. Non-linear. The right.
Okay, well,
Why was it actually?
Let me get
it's not a linear or non-linear. We're going bigger than that today. It was just curious if anyone knew. It's absolute value. It's an absolute value function, the V's. And then for another point, number 13 is another kind of function you learned about in algebra class. It looks like an arm. What kind of function is that? Oh, I heard it from somebody. It was a square root function. Okay, just curious to see if you knew things. It's fine that you don't. Heck, we're only to linear, non-linear. You don't have to know other kinds yet. Okay, moving on to number 14, which is covered up a bit. We need to put each equation into standard form. So what do I need to do on number 14? Someone want to help me? I would love to hear from table 4. They're being super plot today. Oh, table 6 wants smiling here. Go ahead, table 6. Subtract 3y. Okay, let's add 3y to both sides. And if you don't want to write this step, you don't have to. So it is 4x plus 3y equals 7. To keep your point, what is A, B, and C?
A is 4, B is 2.
Okay, you can add the point then. Okay, I'm needing help with number 15. Number 15. Need to rearrange it into standard form. Yes, Mia? I'm going to save him. Go ahead, dear. By -1? Okay, so if I multiply everybody by -1, I've got positive 6y minus 7 equals negative 8x. Now what? Add the 8x to both sides. So I've added 8x, and I have 8x plus 6y minus 7 equals 0. And I get some people did all this in their head. That's great. But some people were confused yesterday after talking to them during 0 periods. I'm trying to show them my work today. Okay, if we add 7 to both sides, we actually end up with 8x plus 6y equals 7. Now, Mia was a genius to think to multiply by -1 first. Is that what I would have done for my first step? Probably not. I probably would have moved the x over, moved the number over, then realized, oh crap, I have a negative x. Now I'll multiply by -1. So but we don't have to be like Mia. We didn't have to do it in this exact order. Mia, can you tell me the A, B, and C? And C is? Eduardo, you better get on your people. They're about to lose you some points. Perfect. Mia, add a point. Arturo, you're dying. Tell me something.
There was another method that you could do for 15. It's just by adding 6y on both sides.
Oh, yeah. You could have. So Arturo is seeing, and that's a good idea. Okay, so it said negative 6y plus 7 equals 8x. Our churro says if you add 6y to both sides, you would have 7 equals 8x plus 6y. Hey, isn't that the same thing as 8x plus 6y equals 7? So if you realize that like our churro did and you can skip straight to that end, that's fine. That is great. If you need to be like me and multiply by -1 and do all the things, that's fine too. Whatever floats your boat. Okay, number 16 is a doozy. It's in slope-intercept form, and we need to put it to standard form. Yes, ma'am.
Wouldn't you multiply by 2?
That's a great idea. If we multiply everybody by 2, we're going to end up getting rid of that fraction. We'll have 2y equals negative x plus 20. It's a great idea. Get rid of that fraction.
Point.
You're going to once you help me finish rearranging.
Okay, and then now you're going to take the 2y and bring that over. No, you're going to take the x.
Okay.
Yeah.
So I have x plus 2y equals 20.
Yes.
Okay, what's the a, what's the b, what's the c?
The a is
What number's in front of the x?
1,
Okay, what's the b?
2,
And the c?
20.
And now you can have your point. Are you volunteering? Yes, dear. Can it be 2y plus what? Would that be in standard form? Is that technically ax plus by equals c? Wouldn't that technically be by plus ax equals c? Not technically in standard form. I get that you see it and you know what the a, b, and c are. And if you're not going to mess up the a, b, and c, that's fine. I'm not going to be that picky. Is that a better answer? Okay. As long as you have x and y on one side, number on the other. I'm not going to be that picky about the order of the x and y unless you go blind on me and tell me that that is a and that is b. Then I'm going to ask Eduardo. Yeah, you could have added 1/2 x to both sides to give it. Again, she didn't do it in the order I would have done it in. I'm a little slow. I would have had to add the 1/2 x. I would have had 1/2 x plus y equals 10. Then I would have multiplied by 2. So she did it a little different than I would, and it's cool. As long as we all end up in standard form and we don't do any heebie-jeebie math, we're good to go. But the fact that she thought to get rid of the fraction first, that's pretty genius, especially when you see number 17. You're like, my God, I wish I thought to get rid of fractions first. Okay, number 17 is the doozy. What would I multiply by? Okay, if I multiply by 4, are all the denominators going to cancel out?
No.
You finally got you a point, I see. Was that not you, dear?
No, it wasn't.
Yes, it was. I know it wasn't your voice. I know your voice all too well, Will. Aha. So finally, you got your point. Good. Let's multiply everybody by 8. Now, Paige is on the right track, but again, if we multiply by 8, we know these two 8s will end up canceling out. Okay, so for my fraction lovers, it is cool if you write the step 40 over 8x, because you distributed, so you multiplied 5 times 8 and got 40, equals 8 times 3 is 24, so 24 over 4y, and then negative 9 times 8 is negative 72. That's cool with me. I have no problem with that. But if Paige already realized, hey, I know what this is going to simplify to, maybe she knew the 8s were going to cancel out and it was going to be 5 anyway. Maybe she realized it was going to be a 6y. She doesn't necessarily have to write that fraction step unless she needs it. So 40 over 8 is 5, 6y minus 72. I'm hoping you're going to want an extra point and you're going to help me rearrange. But, you know, I can keep on dreaming.
Plus 6y.
You are not the person I'm talking to. He knows who I'm talking to. And add 6y. Why would I add 6y? Okay, let's subtract 6y. And we would have, and I can't show that because I'm out of room, 5x minus 6y equals negative 72. And I can now know, hush, I now know my a, b, and c. Will you tell me my a, b, and c so we can give your group another point?
A is 5, B is negative 6,
Uh-huh.
C is
Negative 72. Perfect, and you can have a point. See how easy that was?
Alright.
Okay. 18 and 19 are going to be Friday's problem because tomorrow we have a quiz, so we're not going to math workshop it. Okay, speaking of quiz, we also have a test on Friday. What is our test on Friday? And that was the fastest you've answered today, so you can have a point for that. I mean, y'all think y'all were on it. He was like in my head, I guess. Okay, if you need to take out your list, you can. But let's face it, it's Wednesday. You got to know this by Friday. We're going to go 17 through 25 today. You got 1 through 16.
Yeah.
Let's do 17 through 25. If you need to look at your list, you can. But if you're looking at your list, you know it's a 25-point grade in the 60% category. So right now, those who know the first 16 are at a 16 out of 25. Let's see what that is. Is that good enough to make you happy? $16 divided by 25. Bless your heart, that would be a 64 in the 60% category. Do you really want that? I didn't think so. You've got to know 17 to 25. How long did I give you yesterday for the first 16?
66.
I gave you 60 seconds. I'm going to be so nice as to give you a full 2 minutes for all 25. So if Alonde gets super stuck, he could probably, like, for some reason, 17 times 17, he just can't remember it. He could probably do that really fast on this paper. He remembers multiplication. He could probably do that one. Does he have time to, on his paper, multiply out 17 through 25? No, he does not. And the 2 minutes includes the time to write your name this time. Yesterday, I didn't include the time to write your name. Okay, so let's see. Let's start with 17. What's 17 squared?
289.
Okay, what's 18 squared? 19 squared? 20 squared? 21 squared? 22 squared? 23 squared? Look, find it out.
I don't know my name.
Oh, well, 24 squared? 25 squared. Okay, does anyone else want to be honest like Seth and tell me you lost your list? Okay, I got some extra lists printing right now. There is one in 17 through 25 that I will not, there are two that you should not forget. One is 25 squared is 625. It's the number 6 and then 25. That one's easy. And then there's another super easy one you should not forget. What is this other super easy one?
20 squared.
20 squared. 20 squared is 400. How are you missing that one? I still have people not get that one.
I
Does
never
anyone
got
else need a list? What do you mean you never got a list? Okay. You need one too? Okay. Oh, and I gotta add paper and then move the list. Okay, so while we're doing it again, remind me 17 squared? 18 squared? 19 squared? 20 squared? If you missed that one, I am going to be mad. 21 squared? 22 squared? 23 squared? 24 squared? 25 squared? Okay, so let's say that Alonde, he doesn't have time to study all these. He got the first 16. He's got 20 and 25, so he would get an 18 out of 25. That would put him at a 72. 72. Now, it's only a 25-point grade in the 60% category, so it's not going to kill you, but man, it's not going to help. It's not going to help at all. Okay, moving along. Let me go ahead and give you back those checkpoints before I forget. I'm not saying this isn't perfect. Maybe it is. I'm just saying the amount of people that have put on to both and didn't really know what they were doing, I need them to actually think it through before they hand it to me again. Say words. Say something. You didn't have to. You probably need to look back over it. Some people just did, and honestly, they probably want to look back over it before they hand it to me, to be honest. Okay, I promise that I will rant for 10 minutes tops. That's it. When the hand is on the 11, I'm cutting off my light. And you're going to get time to work back on this checkpoint and make sure you finish those notes we skipped. So we are going to do a little new notes, but not that much, because you need to get some chance to actually do this checkpoint right. Okay. Whew. In our notes, we got a little topsy-turvy due to Miss Compton not being able to copy things correctly. Let's see. We need to be on page 9, which it looks like this. We worked on the back side of this yesterday. I didn't hand you back yours now, should I?
You had it large.
You did. That's what I did. Just what was him down below. It's Patrick. I mean, it's
I need
Lord
that.
Jesus.
I need
Something else. Is the perfect squares quiz? I can give you a checkpoint for the quiz. You're going to have to come 0 period.
Fine,
Ben, give me a few minutes. Gotta remember where I put all my stuff. Okay. Let's see. So we're going to do a little bit of notes today just because we can't get further behind. Back to that darn eclipse just threw us off. Threw off my whole planning for this 9 weeks. Everybody's thrown off. So today we're doing 2-3. But the good news is our quiz tomorrow does not include 2-3. The good news is, when we say that again, our quiz tomorrow does not include 2-3. Eventually, though, you realize we're going to have a test, and this is going to be on the test. Tyreek, I just saw my note to myself. I will actually do that tomorrow. I don't know why I put it in here and not in my regular thing. Okay. Thank you.
Yeah, I was talking
I wrote a note to myself yesterday to email somebody, and I didn't do it. I'll actually do that today and get my life together. Okay. Where's the best of that? Don't you hate when that happens and you can't get your hands on things?
Hey, Miss Compton,
Mm-hmm.
this checkpoint says 380 algebra 2.
I knew somebody eventually was going to notice that. I hate to tell you this, but normally all checkpoints are exactly the same. The quizzes and tests have fewer questions. But again, back to you took an advanced math class because you're so smart. So sometimes y'all tend to be in the same world. Bless your heart. Bless your heart. Okay, so Mia that confused the mess out of me now. Don't you hate it when that happens? Okay, I got this. Let's see, rate of change is a ratio that compares how much one quantity changes on average relative to the change in another quantity. So that first blank on the 2-3 notes is rate of change. You eventually stop calling it rate of change. Eventually you call it slope. And rate of change is seriously the change in y divided by the change in x. Does that not sound like slope to you? Change in y in the numerator, change in x in the denominator. And then if you are to get far enough along to maybe do calculus, they refer to it as delta y over delta x. Okay, so if we need to find the rate of change, we're going to see the change in y over the change in x. So right now our x is going to be the minutes, the y is going to be the temperature, and so if we're wanting to know change in y over change in x, we're going to have to subtract like what is happening over here. What's the 143.6 minus 139.4? Did you get 4.2? I don't know. I think it's my air conditioning. I smelled it too.
Why, is the heat on?
No.
Would you get 4.2?
Yes, ma'am.
Fire.
And
it.
then
Burning all the dust.
let's see if 139.4 minus 133.1 is also 4.2. And since we're going down each time, I'm going to put a negative 4.2. Ooh, it wasn't. I got 6.3. And then 133.1 minus 126.8. I got 6.3, which makes me question, can I do math today? And then 126.8 minus 118.4, and I got 8.4. So negative 8.4. So it's not changing on a consistent basis, or at least that's what I thought. But I'm not paying any attention because I'm like, Gracie, I smelled the burning smell. I'm not paying any attention to the fact that, is it changing by 1 each time in the x's? No. Right here it's changing by 2. Right here it's increasing by 3. 3 and then 4. So to find the rate of change in the data set, and Ms. Compton made life way too complicated having to find them all, we really only have to do it with the one if they're increasing at a constant rate. So I really just have to do our normal kind of slope formula of I pick a point in the y minus another point in the y. So I'm going to use, this is my y2 minus my y1 over, and since I use this as my y2 and this is going to be my x2, since I use this as my y1, this is going to be my x1, and you're like, Ms. Compton, rate of change and slope are pretty much the same thing. Yes, they are. So 139.4 minus 139.2, we already found that. It was negative. I wrote 0. It should be 0. So negative 4.2 over 2. And what does that reduce to? What does this reduce to? Thank you, Eduardo. You can have a point. Okay. So we found that rate of change. The next problem is actually a little further down. That paragraph was supposed to go with this problem. I just didn't bother to read it. The next problem says time and distance. It's showing us a table. I see it's going up by 2s consistently this time. I see it's plus 2, plus 2, plus 2, plus 2 in the x's. And what's it going up by in the y's? Who said it? You can have a point.
I said it.
Okay. So since it's doing this constant rate, it really doesn't matter what points I pick. It didn't matter on the last one either. But I kind of already know what the answer is going to be. Does anyone else know what the answer is going to be? So I can actually plug in my slope formula like I did before. Or I could just tell you the answer from here. How do I know the answer? I know what the answer is. I know what the rate of change is right now. No. Aren't we doing change in y divided by change in x? What's the change in y? What's the change in x? The change in x is 2, right? So the answer is 6. Yeah, eventually. So if we went back to our last one, heck, Ms. Compton didn't have to do all the things either. Heck, negative 4.2 divided by 2, isn't that what I got when I did the change in the slope formula anyway? So aren't I making my life too complicated? If there's a pattern, just changing y divided by change in x, you got your answer with rate of change. Okay, so we're looking at our next one, and it looks a little harder. Why does it look harder? It's got time, so we need to see, is there a pattern in the time? It don't look like it. How much is it going up by this time? 7, and how much is it going up by over here? 26 to 61. It's not going to be 3. 35. You can have a point for being useful. And then I know the answer to the rate of change from here. Do you know the answer to the rate of change from here? I know the answer. What's the answer? This. Because we're going to do the change in y divided by the change in x, and that is the answer. See, I knew I was giving you a point for a reason. I knew I was giving you a point for a reason. No. You proved your use. I knew you would. You could use any 2 points in the chart. So if you wanted to do, for instance, here, where it was changing by 6 seconds, And 71 to 101 is 30. Isn't 30 divided by 6 also 5? Now, is this always going to work for any data set? No. The data sets we've been given are clearly a linear data set. Is this always going to work? No. Just like you don't use the slope formula when it's a quadratic, do you? The slope formula only works with a line. So this rate of change thing's only working with linear data. So if there's not a pattern, it's not going to work out. Okay, and then let's flip. We'll do 4 and 5, and then we'll stop there and let you work on your checkpoint. On number 4, I need an answer. And I'm going to be weird and choose 13 and 15. So I went up by 2, and I don't know that one. You need to figure it out.
Anyone else to figure this
That would be nice.
take that,
724.
What's the final answer then?
It's gone up by 724.
I understand that, but what's the final answer for rate of change? Kelsey, you can have a point. Okay, so Arturo realizes, hey, it's increasing by 724, but I'm asking for the rate of change, so I need the change in the y's divided by the change in the x's, and the answer is 362. Again, if Kelsey forgets this useful trick, and she needs to do y2 minus y1 divided by x2 minus x1, rate of change and slope, they're the same beast, the way that some people have nicknames. So if you get stuck, you can always go back to your handy dandy slope formula. Okay, and then number 5, I need help with that one. I'm going to use 4 and 7 and 27.7 and 20.8. I need to know the rate of change. I heard 2.3. Is that correct? Mackenzie, you can have a point.
What do you do?
Okay, so what they did in their calculator is I know you know 4 to 7 is going up by 3. If you do 20.8 minus 27.7, what do you get? You get negative something. You get negative 6.9 when you try to find out the difference between here and here. So if you do 20.8 minus 27.7, the difference between those 2 points is negative 6.9. And then for rate of change, all we're doing is the y's divided by the x's, so negative 6.9. And that's how we got negative 2.3. And now you get a point. Okay, are there any questions about this? If you're trying to be an overachiever, because we are a little behind in life, I'll give you that. If you're trying to be an overachiever and you already know how to do slope, my God, be a genius and go ahead and work through some on page 10 and page 11, because the next thing we're talking about is slope. Can you calculate it? Can you do stuff with it? But I'm going to stop rambling, because Lord knows you need a chance to work on that checkpoint. You need to get that checkpoint right. You want to bring it to me when you're done with it. I've got to find Ben a copy of it.